So if you haven't made a choice yet, go ahead, make a choice. All right, everybody's good? I'll wait a little bit. Okay, that's it. Let's see what people said. Okay, E with a few D's. So let's take a look. Okay, to get the instantaneous velocity, we need to get the v as a function of t. So that's the time derivative of x with respect to t. So remember, the x was t cubed plus 2.0t plus 4.0. So you do the derivative of t cubed. So what is derivative of t cubed? Yeah, 3t squared. What's the derivative of 2.0t? Yeah, 2.0. What's the derivative of 4? 0. Okay, that doesn't have to be there. All right, now we just simply take t is equal to 2.0 seconds. So then v, we just plug in 2.0 wherever we see the t. So we have 3 times 2.0 squared is 2.0. 3 times 2 squared. 2 squared is 4. 3 times 4 is 12. 12 plus 2 is 14. So 14 meters per second. Okay. Any questions about this? Yeah. Oh, you mean, why did I, you mean in the answers? You mean, why did I put a 0.0 here and not a further? Oh, yeah, I was trying to, okay, because we made this big fuss about significant digits. I was trying to not corrupt you on this. I'm trying to give 2 significant digits for everything here. So if you even notice, I was even putting a dot on the 60 here to tell you that the 0 was significant. Yeah, it's not a big deal. Good question. All right. Any questions about that? Because we're going to move to a new topic. We're actually getting a little bit ahead of the course pace, which I've never had a class complain about this because that means we get to review more before the quiz or the test comes. So, it has this unintended consequence that your pre-assessment doesn't really become a pre-assessment. I kind of know some of the stuff, but I don't care. Okay, so we're going to talk about motion with constant acceleration. And be forewarned, I'm going to do some derivations. I might not finish it today. I'm going to do derivations, but you don't need to know the derivations. You don't need to remember them. You won't be asked to derive them. They're going to be a little complicated. Okay? I've noticed in your textbook they don't actually derive most of the things I'm going to show you. So I'm going to show you some stuff that's not in your textbook, but I also think because most of you are scientists, engineers of some sort, you kind of want to see where the things come from. You don't want to just be handed a plate of stuff and say, here it is, it's right, accept it. So I'm going to show you where they come from. Okay? But the point is, there's a little work involved in getting the stuff. I'm going to show it to you, but you don't need to derive it. So don't let that bother you. Okay? So we're going to talk about motion with constant acceleration. So by constant acceleration, that means the case where the acceleration is, you guessed it, constant. It doesn't change with time. So as a result, the instantaneous acceleration is the same as the average acceleration. That's not really surprising. If the acceleration is not changing, then saying instantaneous or saying average doesn't really matter. They're all the same accelerations, right? Make sense? Constants. Okay, so we wrote A for the instantaneous acceleration. or we just call it the regular, or we just say acceleration, and by default it means instantaneous acceleration. But it's also equal to the average acceleration if we're talking about constant acceleration. Okay, we're staying in one dimension here. Everything's still in one dimension. Okay, but what was our formula for the average acceleration? It was in a given time interval, it's a change in the velocity over the change in time. Okay. Now, in what I'm about to do here, let me use v will be the final velocity, and v0 will be the initial velocity. Now, your book uses things like vf for v final velocity, and vi for initial. You can switch that up if you want, but the thing is, the way I'm writing the formulas is sort of the way most people write the formulas, and so I'll call it v for the final and v0 for the initial. I'm trying to give it, because to me the formulas look a little nicer this way. Okay. So what we're going to do is we're going to say, okay, delta v is v final minus v initial, so this will be v minus v0 over delta t. Okay. And so I had an a over on this side. Now, what can we do with this formula? We can multiply both sides by delta t, and then we have a times delta t is equal to v minus v0. Okay. So remember at the beginning I said we're going to do a whole bunch of math derivations. It's kind of boring, but it gives us the formulas we're going to use. Okay. Now what I'm going to do is I'm going to write down a formula for v in terms of v0. So I'm going to bring this guy to the other side. Let's actually make the v stay on the left side. So, all right, so what I'm going to do, two steps. I'm going to bring v to the other side, so it'll be v0 plus a delta t, but I'm going to write it on the left side like this. Hopefully nobody's confused by that. Okay, you can do two steps like that. Okay. So this is equation number 1, my box result. Okay. And so let's just write the v. This is equation number 1 in the box. Any questions about that? Yeah.
We need to know how, like, we reach the equation, or just like.
Okay, let me put it this way. You don't need to remember any of the stuff, but if you can do it, it means you kind of know what's going on. If you can't do it, it kind of means you're not really sure what's going on. So if you are comfortable with the derivation, it's a good thing. Okay? We're not going to test you on it. Got it? Okay. The next thing I'm going to say is, in my notes, I actually, I do this in more detail because I did this when I was teaching back in North Carolina State. Somebody asked me, how do you derive this equation? But so what I'm going to do is I'm going to skip a step in my notes. If you want to see the step, the real derivation, you can see it there. But I'm going to skip a step just to make the discussion a little bit smoother, and just say the following: that the average velocity in some time interval from v, this is the initial, this is the final, that the average velocity will be equal to the final plus the initial divided by 2. Does that make sense to you? If you take the final and the initial divided by 2, you average those, you get the average velocity. Okay? There's actually a step involved in how you derive it. If you want to see this, if you are a skeptic, which is kind of, I'm a skeptic, so I have to admit, I wouldn't, if I was sitting in the audience, I would say, hey, professor, I would like to see the derivation, please. Then I would show you something like this. This is in the notes. If you have constant acceleration, then the velocity versus time is a straight line like this. Okay, it's a straight line like this. And then if you have, here is the final velocity, the value of v here, okay? And this is the initial velocity, v0. This is delta v, this is delta t, okay? And now what you can do is make the argument that the average velocity, which is delta v over delta t, that's the definition of the average velocity, is the same as the value of the velocity at the middle time point. Okay? So in other words, if you want the average velocity, which is delta v over delta t, that's essentially, what is delta v times delta t? It's going to be equal to I'm now going to explain the whole thing. I should have just derived the thing, okay? Basically, the value at this midpoint is equal to delta v over delta t. Okay. Everybody okay with that? All right. Okay. So that's my second formula. And now the next formula, we have that, oh, okay, the next formula is we're going to go back to the definition of V average. V average is equal to, by definition, delta x over delta t. But let's let x is equal to the final x, and let's say x0 is equal to the initial. Okay, so that looks stupid. X equals the final x. Let's use the word final position, and x0 is equal to the initial position. Okay, so then we have delta x is equal to x minus x0 over delta t. So now I have two formulas for V average. I have this formula, and I have the formula from box number 2. Okay. So I have x minus x0 over delta t. I told you this is a little bit boring. We'll just take a few more minutes. So I have this guy is equal to V average. This guy is also equal to V average. And now what I can do is I can multiply both sides by delta t. And then I have x minus x0 is equal to 1/2 v plus v0 times delta t. And that's my box number 3. You're probably wondering how many boxes we have to do here. Plus v0 times delta t. Okay. Any questions about that? Everybody's okay so far? All right, let's keep going. We have 2 more things to derive. So we're going to use this number 3 using 3 and number 1. So that's why I wrote it on the board, so you can see it here. V is equal to v0 plus a delta t. We have, okay, so what I'm going to do is I'm just going to copy this guy again. X minus x0 is 1/2 v plus v0 delta t. That's just number 3. And then number 1 was v is equal to v0 plus a delta t. Everybody's good on that? That's what this guy says. V is equal to v0 plus a delta t. And then I'm going to work on this side. So this side will become 1/2 2v0, because I have a v0 here and there's a v0 there, plus a delta t times delta t. I know it looks a little complicated, but now I'll take the a first, the term with the a first, and I have 1/2 a delta t squared, because there's 2 delta t's. Oh, sorry, thank you. That was perfect. Well timed. And then we have 1/2 times 2v0 delta t, so we get v0 delta t. Okay, so now we have this magic formula that's maybe the most used equation for a constant acceleration. You'll probably use this one more than any of the others. V0 delta t. So that is the derivation of this formula that you use a lot. Number 4. X minus x0 is equal to 1/2 a delta t squared plus v0 delta t. By the way, these things that we're deriving are called the constant acceleration formulas or the kinematic formulas sometimes they're called that. So this is 4, this is 3. Any questions about this? One more to derive. Okay, so now what we're going to do is we're going to consider this one. So we take using number 4 and number 1 again. So number 1 is v is equal to v0 plus a delta t. But what I'm going to do with number 1 is I'm going to massage it a little bit so it's a little bit in a different form. So v is equal to v0 plus a delta t is number 1. But what I want to do is I want to write it as a delta t is equal to v minus v0, and then I'm going to write delta t. Okay, solve for delta t. So delta t will be v minus v0 over a. So this is the thing I'm going to use, which is the reworked version of number 1. Okay. What I'm going to do with this is I'm going to get rid of delta t from equation 4. And this formula will be useful when you don't know what delta t is. When you don't know the time interval, you can use it to solve for the things you need. Okay. So let's now, oh, I lied. We're not using number 4, we're using number 3, sorry. We're going to use number 3. We didn't use it yet, so it was on the next page of my notes. So we're going to use number 3, which is this one here. And we're going to get rid of the delta t here. So let me write number 3, equation 3. So we have x minus x0 is equal to 1/2 v plus v0 delta t. And now what we're going to do is we're going to take this formula here for delta t and plug this guy in instead. Okay? Everybody with me so far? I just have 2 lines left and the derivation's over. X minus x0 is equal to 1/2 v plus v0, and then v minus v0, and then divided by a. Interesting? Okay. Let me multiply by 2a to both sides to get rid of this 2 and this a here. Then I'll have 2a, oh, 2 off the bottom, sorry. X minus x0 is equal to v plus v0 times v minus v0. Does anybody recognize this formula? There's another way of writing this guy. Remember a plus b times a minus b, that thing? That's a squared minus b squared. Okay. Yeah, when you multiply this out, the cross terms, they go away. So this ends up being v squared minus v0 squared. And that's the formula, the last formula. V squared minus v0 squared is equal to 2ax minus x0. And that's the last one. Okay. So this formula is useful when you don't know delta t or time. All right, so we've succeeded in deriving the constant acceleration formulas. So let me now summarize what we have here. We have, in summary, we have these formulas. And you will get to know these. They will be your friends. Okay. V is equal to v0 plus a delta t. We have v average is equal to 1/2 v plus v0. We have x minus x0 is equal to 1/2 v plus v0 delta t. Okay. And then we have x minus x0 is equal to 1/2 a delta t squared plus v0 delta t. And then we have v squared minus v0 squared 2a x minus x0. Okay, so your responsibility is to be able to use these equations to solve problems. Okay. Now, the natural question that I've taught this class a lot of times, the question I always get is, how do I know which equation to use? Okay, there's all these equations. First thing I should mention is these two equations are not all that useful. They're more for driving the other three. So these guys are the ones that are the real workhorses. Okay, so those are the ones that you generally will be using more. So, but let me answer the question, which equation to use? And the strategy is, if possible, pick the one, or maybe there's more than one, such that you know all the variables. By variables I mean like v, v0, a, x, x0, delta t, except one. And then, which you can use, you can then determine. All right? So what do I mean by this? Suppose you are given the initial velocity, you're given the final velocity, you know the acceleration, and you want to know the displacement. Okay? So you're given final velocity, initial velocity, acceleration, you want to know the displacement. So we know v, we know v0, we know a, and we want to know x minus x0. So you see this equation is perfectly set up to make your life simple, right? Because you know everything, you don't know this one, and that's the one they want to know. If they wanted to know something like, if you wanted to solve for delta t, then this equation here is not that useful because you don't even have a delta t in it, okay? So you want to pick an equation that has the thing you're trying to solve for, but you know everything else. And very often one of these equations will have all of those. Okay. Any questions about this? All right, this is a good place to stop, so I'll see you guys next time.